I want to talk today about equivalent algebraic expressions because sometimes expressions can look different but actually be the exact same thing. And this sometimes gives people some difficulty with algebra. So I'm going to go through a variety of examples. Let's just start with something really simple that we already know. X plus x, we know that that's equivalent, identical to 2x. All right, if I were to put in x equals 1, let's say, 1 plus 1 on the left would equal 2 times 1 on the right, 2 would equal 2. And so we know that x plus x is equivalent to 2x for all values of x. Here's another example. If I had 1/2 times x, because I can think of 1/2 times x as 1/2 times x over 1, and then multiply the numerators and denominators, x divided by 2 is identical to 1/2 x. Similarly, if I had 2/3 times x, the x can be thought of as x over 1, and so it's 2 times x, 2x, over 3 times 1, 3. These two expressions are equivalent. Okay, here's another category of situations. We know from our work with fractions that 1/5 plus 2/5 would equal 1 plus 2. Add the numerators. We have our common denominator of 5. And we could reduce that to 3 over 5. Now with algebra, let's suppose I had x over 5 plus 2 over 5. Again, I would add my numerators, x plus 2. And I can't put those together because they're not like terms over 5. So these two terms are equivalent. If I put a value of x in, like I did up above, 1 over 5 plus 2 over 5 would equal 1 plus 2, which is 3 over 5. We know that's true. And there's actually one more thing I can do. I could write this expression as 1/5 times x plus 2. And the reason I can do that is because that would be 1/5 times the bracket x plus 2 over 1. And if I multiply the numerators, I get x plus 2. And if I multiply the denominators, I get 5. So I think you see what I mean. There's lots of ways to write expressions in different ways that are equivalent even though they look different. All of these represent the same thing. So depending on what you're doing with your work, you might want to write your expression in one way versus another. Okay, let's talk about some other common situations that come up with equivalent expressions. If you have 2/5 and I multiply numerator and denominator by 2, let's say, I know that 2 over 2 is 1. And so 1 times the original thing will give me something that looks different but is equivalent to the original thing. So we know that 4/10 and 2/5 are equivalent. Now we can do the same thing with algebra. If I had x plus 5 over 2, I could multiply numerator and denominator by 2, because that's just 1, and multiplying my original expression. In other words, I'm taking my original expression and multiplying by 1, so this should be equivalent to that. When I then do the multiplication, my expression is going to be 2x plus 10 divided by 4. And so this expression is equivalent to that expression. If I pick a value of x and plug it into one expression, for example, if I picked x equals 0, I would have 0 plus 5 over 2. I'd have 5 over 2. And if I plug 0 into here, I'd have 2 times 0 is 0 plus 10, 10 over 4, which is also 5 over 2. So these two expressions are equivalent. They look different, but they're the same. Let's just look at one more common situation dealing with negatives. If you have negative 2/3, we know that that's equivalent to negative 2 over 3, which is equivalent to 2 over negative 3. The negative can go in front on the numerator or on the denominator. Well, with algebraic expressions, the same thing applies. If I have x plus 1 divided by 2, and I have a negative in front, then that expression could be written with the negative on the numerator, but we'd have to bracket that. or with the negative on the denominator. And just with the second term, if we wanted to distribute that, this would all be equivalent to negative x minus 1 over 2. So all of these expressions are different ways of saying the same thing.